What is the difference between speed and velocity? Imagine you're riding a bicycle around your neighborhood. You're moving fast and having fun. But suddenly your friend asks, "Are you talking about speed or velocity?" You stop and think, "Oh wait, aren't they the same thing?" Nope, they're not the same. Let's dig deep and understand them one by one with real-life examples, formulas, comparisons, and smart tricks to never forget the difference. Chapter 1. The Basics. What is motion? Before we jump into speed and velocity, let's talk about motion. Motion means an object is said to be in motion if it changes its position with respect to time. So if you're sitting still equals sign no motion. But if you start running, biking, or even walking equals sign you're in motion. Now let's bring in the two stars of motion, speed and velocity. Chapter 2. What is speed? Definition of speed. Speed is how fast an object is moving. It tells you the rate at which distance is covered. Keyword: distance. Speed is all about distance, how much ground you cover, no matter which direction. Units of speed: meters per second, kilometers per hour, miles per hour. Example of speed: imagine you cycle 10 kilometers, so your speed is 5 kilometers per hour. Simple. What speed tells you how fast you're going, but not where you're going. It doesn't care about direction. So whether you're going straight, turning, or looping in circles, speed just tells us how fast, not which way. Chapter 3. What is velocity? Definition of velocity. Velocity is the speed of an object in a specific direction. It's like a smarter version of speed because it tells how fast and in which direction. Keyword: displacement. Velocity deals with displacement, not distance. Units of velocity: same as speed, ms, kmh. But here, direction is important. What is displacement? Displacement equals sign shortest distance between starting and endpoint plus direction. Let's say you walk for kilometers east, then come back for kilometers west. Your distance equals sign 8 kilometers. But your displacement equals sign 0 kilometers, you came back to the starting point. That's where velocity is different. Your speed equals sign 8 kilometers total time. But your velocity equals sign 0 total time equals sign 0 velocity. Even though you were walking, your velocity becomes 0 because there is no net displacement. What velocity tells you how fast you're going and in which direction. If you change direction, velocity changes. Chapter 4. Speed versus velocity. Main differences. Feature: speed, velocity. Definition: distance covered per time, displacement per time. Type of quantity: scalar, no direction, vector, has direction. Depends on distance, displacement. Can be 0, no, unless object is stationary, yes. If object returns to starting point. Always positive, yes, can be positive, negative, or 0. Example: 60 kilometers per hour, 60 kilometers per hour east. Chapter 5. Real life examples. Example 1. Round track running. You run around a circular ground and come back to the starting point. Speed: total distance time you did run. Velocity: 0, no net change in position. Example 2. Driving a car. You're driving north at 50 kilometers per hour. Speed equals sign 50 kilometers per hour. Velocity equals sign 50 kilometers per hour north. If you turn around and drive 50 kilometers per hour south, speed equals sign still 50 kilometers per hour. Velocity equals sign minus 50 kilometers per hour because direction reversed. Chapter 6. Scalar and vector quantities. Scalar equals sign only size or magnitude. e.g. distance, time, temperature. Vector equals sign size plus direction. e.g. velocity, displacement, force. So, speed equals sign scalar. Velocity equals sign vector. That's a big reason why they are different. Chapter 7. Trick to remember. Speed is how fast, velocity is how fast and where. Or, speed cares only about distance. Velocity cares about direction too. Or, speed is like a car's speedometer. Velocity is like GPS, it shows speed plus direction. Chapter 8. Negative velocity. How? Can velocity be negative? Yes. Let's say you define the forward direction as positive. If an object moves in the opposite direction, velocity becomes negative. Example: a ball thrown up with positive velocity. It falls back down, velocity becomes negative, opposite direction. Speed is always positive, but velocity can be negative. Chapter 9. Can speed and velocity be same? Yes, if motion is in a straight line in a fixed direction, then distance equals sign displacement. So, speed equals sign velocity in magnitude. But if there's any change in direction, even if speed stays same, velocity changes. Chapter 10. Acceleration depends on velocity. Even if speed is constant, velocity can change if direction changes. This is why a car turning a corner is said to be accelerating, because its velocity is changing even if speed remains the same. Chapter 11. Final comparisons. Situation: speed, velocity. Walking 10 kilometers in a straight line, 10 kilometers per 10 kilometers per hour test. Walking 5 kilometers, then back 5 kilometers, 10 kilometers per hour 0. Car turns but maintains same speed, constant changing. Object at rest 0. Chapter 12. Summary like flashcards. Speed. Scalar, no direction, uses distance. Velocity. Vector has direction, uses displacement. Same speed, but changing direction equals sign changing velocity. If object returns to start equals sign 0 velocity. Velocity can be negative, speed cannot. Both have same unit ms or kmh. Chapter 13. Quick questions for practice. 1. You drive 100 kilometers into hours. What's your speed? Speed equals sign 100 divided to equals 50 kmh. 2. You go 50 kilometers east and return 50 kilometers west in 2 hours. Speed equals sign 100 divided to equals 50 kmh. Displacement equals sign 0, so velocity equals sign 0. 3. Can velocity be more than speed? No, velocity speed always. Ball moves 20 m forward and 10 m backward in 3 seconds. Distance equals sign 30 m, speed equals sign 10 m per s. Displacement equals sign 10 m, velocity equals sign 3.33 m per s. Final thought. Speed is like listening to music, it tells how fast the song plays. Velocity is like dancing to that music, it tells how fast and which way you're moving. Homework: try yourself. 1. Define speed and velocity in your own words. 2. Write one real-life example where speed and velocity are different. 3. Create a small table comparing 3 differences. 4. Draw a simple picture of you walking to a shop and back label speed and velocity. If you ever feel confused again, remember, speed is simple, velocity is smart. Hello students, let's get to know me. The type of videos I make here are very important for your school, college, and higher studies. I do a lot of research and find answers to your questions. But for physical problems, I make voiceovers through AI. I upload 1 videos here every day. If you have any problem, please comment and let me know what your problem is and I will try to answer it as soon as possible. Thank you on behalf of your school YouTube channel.